Welcome to Ask and Learn.
Question number 133. Air is heated and dehumidified in an air conditioning system consisting of a heating section and an evaporative cooler. The temperature and the relative humidity of the air when it leaves the heating section, the rate of heat transfer in the heating section, and the rate of
Here's a clean,
water
professionally
added to the
formatted
air in the
presentation of the
evaporative cooler
calculations
are to
shown in
be
the image.
determined. So, firstly,
Application of the
I
work
will
energy
draw a
theorem,
drawing.
wet. From the work energy theorem, the force F is given by F equals frac text
This
KE,
is the
where
heating section,
KE equals kinetic energy, S equals stopping distance. I'm given for object A, FA
and
equals
this is
frac
the
100,000, 0.10.
humidifier
For object B, FB equals frac 225,
where water
1500 equals
sprinkles.
0.15 text makes N. And force ratio frac FA, FB equal frac 0.10, 0.15 equal frac 2
Here
ohm
enters
result.
this
On the
portion.
box frac FA, FB.
Entering
Would you like a PDF version
parameters
of
are
this explanation?
15 degree temperature, 55% relative humidity, and 30 cubic meter per minute flow rate. And the outside temperature is 25 degree and 45% relative humidity. Now, assume the three conditions. This is a steady flow process, and thus the mass flow rate of dry air remains constant during the entire process. So, m dot A1 is equal to m dot A2 is equal to m dot A. Second, dry air and water vapors are ideal gases. Third one, kinetic and potential energy changes are negligible. So, assuming the wet bulb temperature of air remains constant during the evaporative cooling process, the properties of air at various states are determined from the psychometric charts, according to which T1 is equal to 15 degrees centigrade and relative humidity at the entry point is equal to 55%. According to psychometric charts and these available values, H1 is equal to 29.8 omega 1 or specific humidity is equal to 0.00581, whereas V1 or the mass flow rate per kg volume per kg 0.824 mass flow rate per minute meter cube per kilogram, as W2 is equal to W1 temperature of wet bulb, 2 is equal to temperature of wet WB3. So here we get the values. T2 is equal to 32.5 centigrade, while the relative humidity at the exit is 19.2%. Here H2 equal to H3 is equal to 47.8 kilo joule per kilogram of dry air. After that, T3 is equal to 25 degree, relative humidity 3 is equal to 45 degree, 45 degree, and here H3 H3 is equal to 47.8. W3 is equal to 0.00888, while wet bulb temperature 3 is equal to 17.1 degrees C. This portion was the first one, inlet. This is the outlet of heating portion, but the inlet of water humidifier. And this portion 3, is the outlet of water humidifier. Coming towards the part B, here at part B, mass flow rate of dry air is V1 dot over V1 is equal to 30 divided by 0.824, which comes out 36.4 kilogram per minute. Then the rate of heat transfer to air in the heating section becomes rate of heat transfer is equal to m dot A into H2 minus H1, putting the values 36.4 into H2 47.8 minus 29.8, and we will get the rate of heat transfer as 655 kilojoule per minute. Now coming towards the part C, the rate of water added to the air in evaporative cooler. Rate of water added. Here is m dot watt 3 minus m dot of watt 2 is equal to m dot A as common into W3 minus W1, putting the values m dot A value 36.4 into W3 value 0.00888 minus 0.00581, and here the answer comes 0.112 kilogram per minute. Thank you.